So far in this LangGraph series, we built conditional and multi-step workflows, graphs that decide where to go based on the data in the state. In this video, we're going to make things a bit more fun and interactive. We'll design a mini number guessing game using LangGraph, where the system makes guesses, checks its progress, and keeps looping intelligently until it gets the right answer or runs out of attempts. This example shows how LangGraph can handle iterations and choice loops, something that's incredibly important when you want your agent to keep reasoning, refining, and trying again, just like humans do when solving a problem. Okay, so without any delay, let's first go into the code. So here I'm going to create a new file. We'll call it number game. Number guess game .ipynb. So from LangGraph, I'm going to import state graph, start and end. From typing, I'll import type dict and list, and we'll also import random here. So let me select the virtual environment. I'm going to create a class called AgentState. AgentState. So here I'll have three variables here. The first one will be name, which is going to be a string. The second is going to be a number, which is going to be list of integer. This is basically going to contain the guesses that the model makes, and a counter, which will also be an integer. So at first we'll have a greeting node, which will contain agent state as its parameter, and it will again return an agent state. Let me write down a drop string here. So let me say greeting node, which says hi to a person. So here what I'm going to do is I'm going to update state name to hi there. I have a state name that I'll pass in the input here. So state name. We will start the game. And what I'm going to do is I'm going to set state counter to 0 and then return state. I'll have another state called or another function called random state. This will contain agent state, so this is going to generate number, it will be random between 0 and 10. So state number will be appended with the random number guessed by this model here, 0 to 10. And then I'm going to update the state counter. State counter will be updated by 1, and then I'm going to return state here. The third function will be a router function, it will say should continue, contain an agent state that will return a string. So this will be a function to decide what to do next. What to do next. Here, if state counter is less than 5, I'm going to enter loop where this will be my state counter value. And I will return loop here. And in the else part, I'm going to exit the loop and I'll return exit here. Now, let me create a graph using the state graph. State graph, and inside this, I'm going to pass my agent state. I'll add a node graph dot add node. So first of all, we'll have a greet node using greeting node function. Then I'll have a random node using random state function. I'll also start adding the edges. So first of all, the first edge will go from start to greet. The second will go from greet to random. And then here we're going to have conditional edges. So add conditional edges. It will start from a random. The function that it should check is should continue. And we'll have two different cases here. The first case, if it's loop, then it should go to random, or if it is exit, then it should go to end. Now I'm going to have one more edge here. If the counter is greater than 5, then I need to end this loop. So one edge will be from random to end. So let me initialize my graph or compile my graph. And if I print my graph, okay, what's wrong? Let's see. So add edge. Okay, add edge edge. Okay, as you can see, so once the model greets the user, then it will enter inside this random node. Then a loop will be carried out if it stays within a certain condition, or else it will exit. Now, what I'm going to do is I'm going to take my input state here. So input state equals to name Abhishek, and the number list will now be empty. And with this, I'm going to invoke my bot with my input data, and I'm going to print my response. So if we run this in loop 1, loop 2, loop 3, loop 4, loop 5, because we've entered a condition for the value less than 5. So in loop 1 it gets 10, in loop 2 it gets 8, 7, 2 and 3 and respectively. So this is how we initialize loop in case of LangGraph. So we'll go to our very beginning of the code and then we'll see what is happening here. So we start by defining this agent state that holds everything about this game. So it holds the player name, the target number, the last guesses, the total attempts, and the range of the number you can choose from. Then we have three things. We have the setup node. So this basically initializes the state, resetting attempts as well as the guesses. Then we have the guess node here, and then we have the decision node or the router node that we have here. So this is where the power of the LangGraph shines. So instead of using a while loop, we simply create a conditional edge that loops back to the same node until a certain condition is met. So the condition is placed here in this particular part of the code. So each loop iteration updates the state, meaning LangGraph remembers the previous attempts, making the upcoming choices context aware. So essentially, we've not completely implemented the game here, but we've turned this simple guessing game into an autonomous iterative reasoning process, which holds the same mechanism behind how our agentic systems plans, act, and retries while solving complex tasks. And I'm going to end this video for now, but what I want you to do is I also want you to add a target number here, and then basically in this particular router function here, basically check if the model has correctly guessed the number or not. If the model has correctly guessed the number, then the model has won the game. Or if the model has correctly or if the model could not guess the number within the given number of attempts, basically the model has lost the game. So I think you can implement that by yourself. In the upcoming video, we'll bring out something new. That is all for this video, and I'll see you in the next one.